A ring wider than the distance to the moon. And thinner than a football field. Picture Saturn shrunk down to the size of a dinner plate, its rings would be thinner than a razor blade laid across it. NASA scientists stared at the Cassini data in 2017 and couldn't explain it. Something that thin should have collapsed. Something that thin should not exist. And the closer they looked, the more it looked like the rings shouldn't even be there anymore.
280,000 kilometers across. That's wider than the gap between Earth and the Moon, with room to spare. If you drove a car along their width, at highway speed, it would take you over 100 days without stopping.
Now shrink that width down. Somewhere in that vastness, the rings get as thin as 10 meters. 10 meters. Less than the height of a 3-story building, spread across a disk wider than a planet.
So how do you even measure that? You're not there. Nobody is there. The nearest human being is 1.4 billion kilometers away, staring at a screen in Pasadena. Cassini didn't touch the rings. It didn't need to. It waited for a star.
Every so often, from Cassini's position, a distant star would pass directly behind Saturn's rings. As its light crossed that curtain of ice and rock, the rings didn't just block it, they flickered it, dimmed it, let it stutter through gaps only meters wide. Cassini's instruments recorded every flicker, every microsecond of light and shadow. That flicker pattern was the measurement. Not a ruler. Not a photograph. A star, blinking through a keyhole 1.4 billion kilometers wide. Inside the operations room, the first readings didn't make sense.
The gaps are too clean. This isn't debris settling randomly over billions of years.
Then it should be thick. Chaotic. Not this thin, not this flat.
For decades, the assumption was simple. The rings formed alongside Saturn, 4.5 billion years ago, and they've been slowly settling ever since, ancient debris, patiently flattened by gravity over an almost unimaginable stretch of time. But something that old should have thickened. Collisions pile up. Wobbles accumulate. Structure erodes into chaos, not into a blade edge of ice 10 meters thin.
A system this fragile, this precise, shouldn't survive 4.5 billion years of chaos. It should be a wreck by now. It isn't. Which meant one of two things was true. Either everything scientists assumed about how rings age was wrong. Or the rings weren't ancient at all.
That second option sounded absurd. Rings, younger than the planet they circle. But the thinness kept pointing the same direction, occultation after occultation, star after star flickering through the same impossible gap. And it turns out, the thinness wasn't the strangest part of the story. It was just the first clue. Because when Cassini kept watching, it caught the rings doing something no ancient, stable structure should ever do. But that thinness led Cassini to a discovery that overturned everything we thought we knew about the rings' age, because the rings turned out to be catastrophically young.
1981. Voyager 2 sails past Saturn and photographs something odd, dark, spoke-like smudges drifting across the bright rings, like fingerprints on glass. Nobody understands what they are. It takes another 36 years and a spacecraft named Cassini to reveal the truth hiding inside them.
Rain. On Saturn. Not water, ice, charged by sunlight and the planet's own magnetic field, peeling off the rings and spiraling down into the atmosphere in invisible streams.
Cassini flew directly through it during its final orbits in 2017, the so-called grand finale, diving through the gap between Saturn and its rings before burning up in the atmosphere. Its instruments tasted the rain as it fell. And the numbers coming back to Pasadena stopped the room cold.
10,000 kilograms of ring material. Falling into Saturn. Every single second.
Enough to fill an Olympic swimming pool every half hour, drained straight out of one of the most beautiful structures in the solar system. Run that number forward, and the math gets uncomfortable fast.
At this rate, the rings have somewhere between 100 and 300 million years left. After that, nothing. Just a bare gas giant, the way it may have looked for most of its life. 300 million years sounds vast. It isn't. Earth's dinosaurs went extinct 66 million years ago. The rings could still outlive the memory of the Tyrannosaurus by only a few hundred million years, a blink, geologically speaking.
Which means the old assumption, that these rings formed alongside Saturn 4.5 billion years ago, collapses. At Cassini's mission briefing, two scientists lay out exactly what that means.
If they were 4.5 billion years old, ring rain this fast should have emptied them out 10 times over by now.
So they're not leftovers from the birth of the planet. They're new. Geologically, almost embarrassingly new.
New rings, forged sometime in the last 100 to 200 million years, maybe from a shattered moon, maybe from a wandering comet torn apart by Saturn's gravity. Nobody knows for certain. What they do know is the timing, and the timing changes everything. Here's the twist that flips the entire investigation. That razor-thin profile from Chapter 1, it was never a sign of ancient stability. It was a symptom. A structure this young hasn't had time to spread out, thicken, and settle the way an old, chaotic system would.
The thinness isn't proof the rings survived for eons. It's proof they haven't been falling apart for very long, yet. And that raises a question the data doesn't answer on its own. Ring rain is dragging thousands of kilograms of ice into Saturn every second. Gravitational chaos should be smearing what's left into a thick, messy disk. So why, after millions of years of this violence, are the rings still holding a shape this precise?
Something is fighting the collapse. Something small enough that it took Cassini years to even find it. But if the rings are this fragile, this fast fading, something has to be holding them back from spreading out, thickening, unraveling completely, right now, while we're watching. And the answer traces back to a handful of tiny moons almost nobody's ever heard of. Their names are Pan and Prometheus. Pandora and Atlas. Moons barely 20 kilometers wide, buried inside the rings themselves or orbiting just outside their edges. Scientists call them shepherd moons. And the name is exact. Their gravity tugs on stray ice particles the instant they drift out of line, herding them back into the ring plane like sheepdogs working a flock that never stops trying to scatter. Without them, the math is brutal. Every particle in the rings wants to spread out. Collisions push some particles inward, others outward, and left alone, that spreading would smear Saturn's rings into a thin, boring haze within a few million years. Flat. Featureless. Gone as a structure long before the ice itself disappears into the planet. Two researchers, reviewing the same Cassini gravity data, land on the same uneasy word.
The resonance from Pan alone keeps the inky gap open. Cut that moon, and the gap fills in within centuries.
So the sharp edges we see through a backyard telescope aren't permanent. They're being actively enforced.
Enforced by rocks the size of small cities. Fighting physics, every second, with nothing but gravity.
So here's the actual shape of the situation. The rings are losing mass every second to ring rain. They're being held thin and sharp by a handful of moons small enough to hide in noise data for decades. And the whole structure has, at most, a few 100 million years left before it's gone.
Now do the math on when you were born. Saturn is 4.5 billion years old. Dinosaurs went extinct 66 million years ago. And the rings you're picturing right now, the ones photographed by Cassini, the ones visible through a $200 telescope in your backyard, are estimated to be somewhere between 10 and 100 million years old. Younger than the extinction of the dinosaurs. Maybe younger than flowering plants. Shift human history back 100 million years. No rings. Or a shapeless disk with none of this structure. Shift it forward 300 million years, and the rings are gone entirely, fallen into the planet as rain, leaving a bare, ordinary gas giant. You happen to exist in the sliver of time in between. Every photograph of Saturn ever taken. Every textbook diagram. Every kid's drawing of a planet with a ring around it. All of it exists inside a window that, on a cosmic clock, just opened, and is already closing.
That's not a metaphor. That's the measurement. 10,000 kilograms of ring material raining into Saturn's atmosphere, every single second, right now, while you watch this.
Cassini didn't just study the rings. It watched them dying, in real time, and then in 2017 it dove into Saturn itself and became part of the story it was sent to record. So the next time someone shows you a picture of Saturn, understand what you're actually looking at. Not a permanent feature of the solar system. A brief, dying structure, held together by moons the size of towns, caught mid-collapse, at the exact moment a species evolved on the third planet with eyes good enough, and telescopes sharp enough, to see it before it's gone.